The next thermodynamic term is the enthalpy. It's also called the heat content of the system, and we define it as the amount of energy available with the system for being converted into different forms of energy. So it is the heat or that amount of energy which gets converted into different forms, different other forms. So it's very important property. Remember, it's a state function. It's a state function. It depends only on the initial and the final states of the reaction or a process. And most importantly, mathematically, this H is equal to U plus PV. Now, we cannot find out its absolute value. We can only find out the change in its value, and we call it delta H is equal to delta U plus. We can do the delta of PV, and we know that it will come out to be delta U plus P delta V plus V delta P. And we know that since most of our reactions, all day-to-day reaction and processes takes place at constant pressure, this term has practically no significance. So what we find is the expression is delta H is equal to delta U plus P delta V, which is the work done. And we put a not above delta H, which indicates it's the standard, or we call it standard enthalpy change. We call it standard enthalpy change, which shows that it is the enthalpy change under standard conditions of temperature and pressure. Now, what we can make out from this formula very easily is that it is equal to the difference of the or change in the internal energy plus pressure volume work done. And we need to understand this, and that from the first law of thermodynamics, we already know the formula that this delta U is equal to QP plus W. We know about this, and we know that in this case the work is done on the system, and when we put it by the system is W is by the system, what we get is QP is equal to delta U plus W, and this equation becomes this one. And now when we compare these two equations, we can easily make out very clearly that this delta H naught is equal to QP. So it is actually, what is the significance of this equalizing both the equations is that it is the amount of energy which is actually being given to a system at constant pressure, this delta H. And from here, this formula, we also know that we can also make out this thing very clear, that as delta V becomes 0, we can know that the work done also becomes 0. So in that case, we call it QV is equal to delta U. So we need to know this. When the heat is given to any system, any particular reaction or any particular system, at constant pressure, it is always equal to the enthalpy change, and at constant volume, it is actually equal to internal energy change. So these are two things which are always related to each other. Now, we must also know one thing very clearly, that though this enthalpy of reaction is a state function, it basically involves that how much of energy has been lost or gained by a system. So this enthalpy, if it is having a sign negative, it shows that the process is exothermic. It means the energy evolves. If it is like this, and what we find is if this delta H is positive, the process is endothermic, and which means energy is absorbed. So these are the two basic significances and sign conventions about the enthalpy is we are having. Now, we need to know one thing more about the enthalpy. Now, we can also make out for enthalpy that delta H is, since it is equal to delta U plus P delta V, at constant volume, delta V becomes 0. Therefore, delta H becomes equal to delta U, which becomes equal to QV. So this is a very important thing, that whenever at constant volume, whatever the amount of heat is given to a system, it becomes equal to what? The enthalpy change or internal energy change of that particular system. Now, we need to know one thing very more important, is that in case of solids and liquids, the change in the volume is almost 0. But for gases, delta V is significant. So whenever a process takes place or a reaction goes on, whenever in that particular process or reaction gases are involved, the change in the volume takes place, and then we need to actually include this change in the volume also in this enthalpy expression. How we can do this? We can do this by simply considering, by changing this formula into this, that delta H naught is equal to delta U plus delta Ng RT, where this delta Ng G is written in subscript. It indicates the change in the number of moles. So it is the change in the number of moles of gaseous substances, and this is always is equal to the number of moles of gaseous substances of products minus summation of gaseous substances, moles of gaseous substances of reactant. So this is how we can easily find out these two things. So what we can do is, whenever we have change in the volume taking place in the reaction or a process, and we want to find out the enthalpy change in that particular reaction, we will use this expression.